Okay, so we will be recording this session. If anybody has any objections with recording, please say so now. Okay. Well, last session we were talking about solenoids and solenoid applications. And so we know that if we have a conductor wire and we wrap it around in a coil and we put a current going through it, we're going to generate a magnetic field. If we turn on or off that current, that magnetic field is going to activate or deactivate. That's a basic principle of many actuators that we can see in many applications in real life. And we saw some videos relating to that. So that's the basic principle of Ampere's law. The strength of the magnetic field is going to depend on the strength of the current and also the permeability and the number of windings that we have in the coil. And any sort of change in the current is going to affect the magnetic field. And that configuration where we have a coil and it's used to generate a magnetic field, I'm going to say artificially or through, or to create an electromagnet, then we call that configuration or that device a solenoid. And it has, as we mentioned, many applications. Now, the next thing we're going to talk about is Faraday's law. And so, oh, Karen's yawn stayed with me. I apologize for that. Remember, when I'm yawning, it's for one of two reasons. First, my breathing, if I can't breathe, then if I yawn, I can breathe. And secondly, my class is maybe boring to even myself. So if I yawn, it's probably one of those two reasons. So I empathize with you if any of you are yawning, okay? Remember, solving stuff with SOSA. Let's make it viral in a good way. So remember, we've seen a bunch of laws. We've seen Ampere's law. We've talked about we've talked about these different effects in magnetism, and so any change in any of the variables that we've been talking about is going to affect any of the other variables. So remember that when we're talking about magnetic fields, we have a current going through a conductor. The current is going to generate a magnetic field. If anything affects the magnetic field, or we have a charged particle or another conductive element going close to that, then the magnetic field is going to be affected. So all of these are related. So what does Faraday's law say? So any change in the magnetic environment of a coil of wire is going to generate a voltage or an EMF, an electromagnetic force, to be induced in the coil. So any sort of change that occurs in the magnetic environment, changing the magnetic field, moving the conductor through the magnetic field, changing the current, any sort of change in the magnetic environment is going to induce a voltage. And that effect is called Faraday's law. And Faraday's law has many interesting applications. And we're going to be talking about them. We're going to see some videos that kind of explain some of these things. Okay, so Faraday's law is again going to be this fundamental relationship that's actually derived from Maxwell's equations. And it says that if we've got a magnetic field and we have a coil that's interacting with the magnetic field, then that coil, give me a moment, let me check something here. If we have a magnetic field and we have a coil interacting with that magnetic field, we are going to have, again, a change in the magnetic environment. And that change in the magnetic environment is going to induce a voltage, an electromagnetic force. And that force is going to be proportional to the amount of turns that the coil has. And it's also going to be proportional to the rate of change of the magnetic field. The rate of change. Remember, this is important, the rate of change, because we're going to touch upon that back when we get to talk about inductance. And then there's that negative sign there, which is Lenz's law, that only states that the magnetic force is the voltage being induced and the current is going to be opposing the change in the magnetic flux. And that's basically Lenz's law. Depending on how the magnetic flux is being affected or changed, the voltage or current that's induced is going to go against that. Okay, so Faraday's law and Lenz's law are very important because they set up many applications in electromagnetism. We just talked about one of them, which is the pickups in a guitar and a speaker and a microphone. All of these are applications of this this phenomenon described by Faraday's law and Lenz's law. But one of the most important applications that we've got are motors and generators. So we know that an electromagnetic force is generated when all of these changes in the magnetic environment occur. Now, could we use these properties to generate something that creates movement, and that movement to be able to be perpetuated into a constant motion? Well, that's basically the principle of an electric motor. And let's see a little bit about how an electric motor is configured, is constructed, and works. Okay, so.
No.
Okay, thank you. So the basic principle of the electric motor then is that we're going to have a configuration where we've got a magnet, let's say a static or permanent magnet. Then we're going to have a coil configuration where we've got current going through it, generating an electromagnet that's going to repel. It's going to be oriented in a way where the forces from the fixed magnet and the electromagnet repel each other, generating a movement. And if we can make the polarity change of the electromagnet, we're going to be able to make that movement be perpetual as long as there's a power supply providing current. And this is the basic principle of a DC motor. Now, there's something called the counter electromotive force, or the counter electromagnetic force. And so that's an interesting principle. So let's imagine that the power supply here is not connected. Let's imagine that we have no power supply here. And as we mentioned, if there's no power supply, that means there's no current, that means there's no movement. We okay up to that point? What do you think would happen if Pedro were to come over here, he were to grab this wire and start turning it? What do you think would happen if Pedro started doing that? Again, there's no power supply here. There's no power supply, so there's nothing, there's no magnetic field generated here. However, there's a permanent magnet here that is generating a magnetic field. Okay. What would happen if suddenly Pedro started turning that that rotor there in the axle? What do you think would happen?
A current is going to be created.
Correct. Very well. Very well done, Omar. And since Pedro is very strong, he's gonna move that. He's gonna move that, and a large current is going to be generated because Pedro is strong. Let's assume now that it's not Pedro, but Pedro is like one of these. Let's say he's a wind bender, a wind whisperer, and he can generate wind. And instead of having the rotor there, I have sort of like a fan configuration, and I start moving that. And Pedro uses his wind power to move that. What's going to happen? What's going to happen? The same thing Omar mentioned. We're going to have a current being generated because of the movement. Now let's say that instead of a fan, with air, I have a configuration where these are paddles, and I've got water moving the paddles. A current is going to be generated. Now let's assume that instead of water making the paddles move, it's heat or steam making the rotor move. There's going to be a current generated because of the magnetic field, because of the induction effect that we just saw in Faraday's law. So the same principle of the motor, but configured differently, where I have a physical force moving a rotor along where there's a coil along a magnetic field, is going to induce a current, like Omar said. Well, that's the principle of a generator. Okay, so the motor is a conversion of electromagnetic energy into movement, a rotational movement, or any sort of movement, a physical force. A generator is going to be the same principle. It's going to be a physical force that is changing a magnetic field and therefore inducing a current. And that principle is really, really important. And so an electric motor versus an electric generator, it's basically the same configuration, but in one, we've got a power supply that's generating a current. And in the other, we have some sort of movement that's, and I'm sorry, in the first one, we've got the current that's inducing or generating a movement. Here we've got a movement that's going to be inducing a current. Okay, and that current can be measured and used for different applications. So let's see a little bit about how that works. Okay, and so as we see there's this relationship between being able to generate with an electromagnetic force a movement, but if we move then something or we invert that principle, we can create electrical energy, and that's the basic principle of a generator. So these two are related. Now, there's many ways in which we can generate electricity. So basically, we're going to have a turbine or a rotor, and we're going to make that rotor move. Now, how can we make that rotor move? There's many ways to do this. And the power plants that you see, actually some that we have around here in Baja California, take advantage of this. What's one of the primary energy sources that we have here in Baja California?
Centinela?
Yeah, what type is that? What is actually, so it's correct. What is actually generating the energy? So we've got a rotor and we have to make the rotor move. What is making the rotor move in that case? What type of energy?
Isn't it geothermal?
Correct. It's geothermal. So basically we're basically taking steam. We're taking steam, and that steam is being able to generate energy. It's being able to generate movement. That movement is basically the first part of a turbine electric generator, and then there's a series of processes that are done there to be able to transmit the electrical energy. But it's basically steam. There's also some energy plants that are based on water. So we've got dams, for example, A dam is basically a way in which we can configure also so the water is generating the movement of the rotor. Wind can also generate these this energy of the movement of a rotor that's the principle of a turbine generator. And so these are the many ways in which we can generate electrical energy, which is the energy that we in the end have in our homes. Okay. Now let's see some application of these.